the mathematics class. This class is for class 9 for chapter Indices, exercise 8. In the previous class we have discussed up to question number 21 from exercise 8. Now this class in the continuation of the previous class. So we will move on to question number 22. What is question number 22? It is if A is equal to C to the power Z, B is equal to and C is equal to, and B is equal to A to the power X, C is equal to B to the power Y. B to the power Y, you have to prove that X into Y into Z is equal to 1. This is you have to prove. Now what I told you that whenever we are doing a question that is required to prove, we take either left hand side or right hand side. So from here we'll start from left hand side. What is there in left hand side? It is given A is equal to C to the power Z. It means that we can say that C is equal to A to the power 1 upon Z. For example, I say 2 to the power 3 is equal to 8. It means 2 can be written as 8 to the power 1 upon 3. And 8 to the power 1 upon 3 means cube root of 8. So it will be equal to 2. So using this concept, we can say if A is equal to C to the power Z, then C can be written as A to the power 1 upon Z. Similarly, it is given B is equal to A to the power X, so we can say that A is equal to B to the power 1 upon X. And similarly, we can say it is given C is equal to B to the power Y. We can say that B can be written as C to the power 1 upon. Now, if what I need X, Y, Z. It means I need to eliminate A, B and C. So what I can say, let us say we'll start from this. It is given that C is equal to B to the power Y. What is the value of B? B is given as A to the power X. From this equation, we can substitute in place of B, we can say A to the power X and B to the power Y, so Y. Like this. You know that power, if it has powers multiplied, and we can write as A to the power XY. Means C is equal to A to the power XY. Then again C can be written as A. A can be written as C to the power Z. So in place of A, I am writing C to the power Z whole power XY. It means power and power will multiply. So C to the power XYZ. Finally, we got C is equal to C times of XYZ. Now we know C only means C to the power 1 is equal to C to the power XYZ. When bases are equal, we can equate the powers. Therefore, XYZ is equal to 1. Now, this was one more way that we can solve it, but it has been solved by this way only. So, I will not discuss this part of the solution. I hope this is understood. It is given A is equal to C to the power Z, B is equal to A to the power X, C is equal to B to the power Y. From C can be written as B to the power Y, but B is equal to the A to the power X, so A to the power X into Y, it will become A to the power XY. Now C becomes A to the power XY. In place of A, we can say C to the power Z, so C to the power Z into XY. So like this, and the equations. Now, let us move on to question number 23. I am solving question number 23. What is that question? In question number 23, question is if A is equal to X into Y to the power P minus 1, b is equal to xy to the power q minus 1 and c is equal to xy to the power r minus 1. Prove that a to the power q minus r into b to the power r minus p into c to the power p minus q. P minus q is equal to 1. This is what we have to prove and this is given. I think this is the most easiest question. You know the value of y, you know the value of a, you can substitute the value of a in a over here. You can substitute the value of b as xy q to the power minus 1 in b, and you can substitute the value of c in this and just solve it out. Let's see. So a can be written as xy to the power p minus 1 whole power q minus r. Similarly, b can be written as xy q minus 1 whole power r minus p, and similarly c can be written as xy power r minus 1 whole power p minus q. Now, if we multiply, x will, first of all we'll open the bracket, so x will get power q minus r and y will get p minus 1 into q minus r. So I am opening the brackets. X will be q minus r into y will be p minus 1 into q minus r. Similarly, in the second bracket, into x to the power r minus p into y to the power q minus 1 into r minus p, and similarly x to the power p minus q and y to the power r minus 1 into p minus q. Now, we will take all the x together. So, x can be written as q minus r plus r minus p plus p minus q. Whereas y can be written p into q is pq minus q, pq minus q minus pr plus r. And similarly, this is the multiplication of these two. Then, since the bases are same, so we'll add the parts. I am directly doing this. QR, this will be QR minus R, QR minus R minus QP plus P, and plus RP minus RQ minus P minus RP minus RQ minus P and plus Q. Now, in this power of x, plus q minus q cancelled, plus p minus p, x and minus x. So finally we got x to the power 0. Something to the power 0 is always 1. Now when you check in this, I'll write pq minus q minus pr plus r plus qr minus r minus qp plus p plus rp minus rq minus p plus q. Now minus q plus q cancelled, plus pq minus pq cancelled, minus pr plus rp cancelled, plus r minus r cancelled, plus qr and minus rq cancelled, plus p minus p cancelled. So here we got x to the power 0 into y to the power 0, or this can be written as xy to the power 0, that is equal to 1. That is your question number 23rd. I hope you all are understanding what I am discussing. In case you have any doubt, you can send me the question on this number. And otherwise, I've started taking problem solving classes. So there also, just be ready with your question, because that has a limited time. Anyway, we move on to the next one. Let's take question number 24. Question number 24, it is given that 2 to the power x is equal to 3 to the power y is equal to 6 to the power minus z. We have to prove that 1 upon x plus 1 upon y plus 1 upon z is equal to 0. This is what we have to prove. Now, if this is equal to this, all the three are equal, so we can equate them to a constant quantity. So we can say let 2 to the power x is equal to 3 to the power y is equal to 6 to the power minus z is equal to a constant k. Let us assume all these are equal to a fourth number, that is k. Now if 2 to the power x is equal to k, it means that 2 can be written as k to the power 1 upon x. 3 is to the power y is equal to k. It means 3 can be written as k to the power 1 upon y. And 6 to the power minus z is equal to k. It means that 6 can be written as k to the power minus 1 upon z. I hope up to here it is clear. Now we know that 6 is equal to 2 into 3. We all know that 6 is equal to 2 into 3. 6, in place of 6 we can write k to the power minus 1 upon z. In place of 2 we can write k to the power 1 upon x into k to the power 1 upon y. Bases are equal, so powers get added. So finally this can be written as 1 upon x plus 1 upon y is equal to k to the power minus 1 upon z. Now when bases are equal, powers you can equate. It means minus 1 upon z is equal to 1 upon x plus 1 upon y. In the next step, minus 1 upon z will come to this side. It will become positive. So finally 1 upon x plus 1 upon x plus y plus 1 upon z is equal to 0. That is the final value. Now we move on to question number 27, second part. 27 is quite easy, but I am doing the second part. Question number 27, second part. It is given a is equal to 3 and b is equal to minus 2. A is equal to 3, b is equal to minus 2. Find the value of a to the power b, a to the power b plus b to the power a. Simply substitute the values of a and b and solve it out. A is what? 3. B is minus 2. B is minus 2 and a is 3. It means 3 to the power minus 2 can be written as 1 upon 3 square plus minus 2 cube. Minus 2 cube means 8. This will be 1 upon 9 minus, because minus 2 into minus 2 into minus 2 will be minus 8. So minus 8. Now 8's 9 LCM will be 9. 1 minus 72. Finally minus 71 upon 9. So 9 7s are 63 and 8 upon 9 minus. That is the final value. So there was nothing to solve in this, only you have to substitute the values and do the calculation. Now let's see which question we can do. I have taken question number 30. This is a bit different, having a different concept, and in between the questions that are very easy, only calculative, so I expect that you are able to solve. In case you are not able to solve, you can give me the question, I will give you the solution. Now in this, what do they say? There is an expression that is given x to the power 4 y square into z cube is equal to 49,392. You have to find the value of x, y and z, where x, y and z are prime numbers. So it means if this portion, the right hand side, can be written in the product of prime numbers, then maybe we get the value something to the power 4, something to the power 2 and something to the power 3 of prime numbers. So in order to write this number in form of prime, what do we need to do? We need to factorize this. Remember, if you get this type of question and it is given x, y, z and prime, or the variables given are prime, it means this has to be factorized. Let's factorize this. It is 4, 9, 392. First prime number is 2. So we will divide it by 2. 2 2s are 4, 2 4s are 8, 2 6 are 12, 2 9s are 18, 2 6 are 12. Again by 2, 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 8s are 16. Again by 2, 2 6 are 12, 2 1s are 2, 2 7s are 14, 2 4s are 8. Again by 2, 3s are 6, 0, 2 8s are 16, 2 7s are 14. Now you can see that there are how many 4s? 1, 2, 3, 4. How many 2s are there? 4 2s are there. And here it is given x to the power 4. It means x will come as 2. Now this 7 and 3, 10 and 8, 18. It means 3, 0 and 7 is divisible by 3. So 3 1s are 3, 0, 3 2s are 6, 9s are 27. Again by 3, 3 3s are 9, 3 4s are 12, 3 3s are 9. Again by 3, 3 1s are 3, 3 1s are, no, not by 3. We will divide it by 7. Now 7 4s are 28, 63, 7 9s are 63, and 7 and 7. It means this number, I am writing it over here, x to the power 4, y square, z cube can be written as 2 to the power 4 into 3 to the power 2 into 7 to the power 3. 1, 2, 3, 4 2's, so 2 to the power 4, 2 3's, so 3 square, and 3 7's, so 7 cube. Now if you compare, by comparing, this is again a new thing for you. By comparing, we have to compare. Why are we supposed to compare? Because they say x, y and z are prime numbers, and this number we have broken into the prime factors. When you compare, you can say x to the power 4 is equal to 2 to the power 4, implies that x is equal to 2. We say y square is equal to 3 square, implies that y is equal to 3. And we say that z cube is equal to 7 cube, implies that z is equal to 7, and that is the final value. They say cube root of a to the power x into b to the power minus 4 is equal to a to the power x into b to the power 2y. Find x and y. This question is almost same as the 30th question or the previous question. This can be written as a to the power 6, b to the power minus 4 whole power 1 upon 3 is equal to a to the power x, b to the power 2y. We know that if it is written square root of 9, it means it can be written as 9 to the power 1 upon 2, 1 upon 2. Similarly, if it is written cube root of m, it can be written as m to the power 1 upon 3. So in this, it is cube root of this total expression. So I have written total expression to the power 1 upon 3. Now this 1 upon 3 power when goes to this side, it will become cube, whole cube, or you can say a to the power 6, b to the power minus 4 is equal to a to the power x, b to the power 2y whole cube. How? Suppose I say that m to the power 1 upon 3 is equal to k. It means that k to the power 3 is equal to m. It's reciprocal. Same was m to the power 1 upon 3 is equal to k. So k cube will be equal to m. Now, when you multiply this you will get as a to the power 3x and b to the power 6y is equal to a to the power 6 and b to the power minus 4. Now again we will compare. So by comparing, when we compare, we will get a to the power 6 is equal to a to the power 3x. Since the bases are equal, so powers will be equated. Is equal 6 is equal to 3x, implies that x is equal to 2. Now in the second case, we can say b to the power minus 4 is equal to b to the power 6y. It means that minus 4 is equal to 6y, implies that y is equal to minus 4 upon 6, that is minus 2 upon 3. That is the value. Next question I am taking as 32nd question. The question is p plus q to the power minus 1 into p to the power minus 1 plus q to the power minus 1 is equal to p to the power a into q to the power b. You have to show that a plus b plus 2 is equal to 0. Now p plus q to the power minus 1 can be written as 1 upon p plus q. You know the reason, because the power was a negative, it came to the denominator and became positive. Into this can be written as 1 upon p plus 1 upon q is equal to p to the power a and q to the power b. Now if you solve, this will LCM will be pq and here you will get p plus q. So I am writing directly, it will be p plus q upon pq. This portion is like this, into 1 upon p plus q. I am writing the first here and second one is here, is equal to p to the power a, q to the power b. Now this and this will cancel. So what are you left with? 1 upon pq is equal to p to the power a, q to the power b. When this pq comes to the numerator, it can be written as pq to the power whole power minus 1 is equal to p to the power a, q to the power b. Or when you separate, it can be written as p to the power minus 1 and q to the power minus 1 is equal to p to the power a, q to the power b. When you compare them, so by comparing, when you compare them, you can say that p to the power minus 1 is equal to p to the power a and q to the power minus 1 is equal to q to the power b. It means bases are same, so you can say that a is equal to minus 1 and you can say that b is also equal to minus 1. Implies that a plus 1 is equal to 0 and b plus 1 is equal to 0. When you add these two expressions, you will get a plus 1 plus b plus 1 is equal to 0. Left hand side will be added to left hand side and right hand side will be added to right hand side. So a plus 1 left hand side of first plus b plus 1 left hand side of second. So this will come a plus 1 plus b plus 1, 0 and 0 make 0. So now finally it can be a plus b plus 2 is equal to 0. That is the final value, or that has been proved. Now we have done in this class, we have done up to question number 32. I expect everybody to revise and practice the questions. And in the next part, I think we will be able to complete the exercise, because there are total 240, there are 7, so maybe we'll be do 5 or 6 or something, we'll see. So be at home, stay blessed, and please revise, like and subscribe and share. Thank you.